Hi guys, so today we're going to talk about different isotopes and how to calculate the average atomic masses that you find on the periodic table. So each element on the periodic table in nature comes with several different isotopes. For example, carbon. If you were to pick up anything made out of carbon, it would have both carbon-12, carbon-13, and carbon-14. All three of those isotopes are going to be in there. The carbon-12 would have 6 neutrons, carbon-13 would have 7 neutrons, and carbon-14 would have 8 neutrons. So they would all have different masses. Okay? Now, because they're all in there and you have gajillions of those atoms, it's easier to just say that the average atomic mass of carbon, if you look at it on the periodic table, it's not 12, 13, or 14. It is 12.01. That 0.01 is letting you know that there's a little bit of it that's carbon-13 and a little bit of it that's carbon-14. Okay? Now, to calculate the average atomic mass of an element, here's the formula. So you're going to take the mass of each isotope, and times it by the percentage of that isotope that's in there. Do that for each of the isotopes, and then add them all together. Okay, so isotope 1, what's its mass, times the percentage of it that's there. Isotope 2 times its mass, times the percentage of it that's there. Isotope 3 times its mass, take its mass, times the percent that's there, and then add them all together when you're done. And that will give you the average atomic mass of the element. The reason we do it this way, instead of just adding all the masses together and dividing by how many we added, is because they're not in there in equal amounts. So for example, copper. Okay? Copper comes in mainly 2 isotopes. Any sample of copper will have both these isotopes in there. Copper 63 and copper 65. So if you look at the molecules of copper, you will have some that are slightly heavier than the other ones, and they're kind of just mixed in there. Most of it is the 63, but some of it is that 65. If it was 50-50, then you just add 63 to 65, divide by 2, the average atomic mass is 64. Easy. But they're not even. It's not 50-50 of both. So we have to take those percentages into account. So I'm going to calculate the average atomic mass of copper here based on these percentages. Okay, so here we have that problem. To calculate the average atomic mass, what I'm going to do is I'm going to take the mass of each isotope, in this case 63 and 65, times it by their percentages. So start off with 63 times its percentage, 69.1917%. Now, remember that percentages, when you're multiplying by them, you should divide by 100 so that you actually get this over 100. So I'm going to take this and go 69.17 over 100, okay, plus, and then I'm going to do the other isotope, 65 this time, so 65 times its percentage, 30.83 over 100, okay, equals, now, first I'm going to simplify this, okay, grab my calculator here, 63 times 69.17 divided by 100. Okay, so this one is 43.5771. Plus, and the other part, 65 times 30.83 divided by 100. 20.0395. Okay, now significant figures here. The reason I'm doing this in parts is because significant figures, that percentage is a measurement. This is not. This is how many protons and neutrons it has. It's a count, so it doesn't matter. But this is a measurement. So because I'm multiplying and dividing in this step, I'm going to round that to the same number of significant figures as my percentage. So I'm going to round it to 4 because each of these has 4. So I'm going to round this to 43.58 plus, and then this one to 0.0, and then round that to a 4. Okay. Now, when I add them, I have 2 decimals each. So when I add them, I will have 2 decimals in my answer. Okay, rules of significant figures. So I'm going to take these numbers and add them. 43.58 plus 20.004, and I get 63.62 AMU, atomic mass units. Okay? It's not 64 because there's more of the 63 than the 65. Okay, so this next problem is magnesium. Right? Magnesium actually has 3 isotopes, and if you were to zoom in and look at them and actually have the isotopes color-coded, it would kind of look like this. Most of a sample of magnesium is magnesium-24, 78.90% of it. Okay, so most of the magnesium would be those purple dots there. However, magnesium-25 and magnesium-26 each exist. It's about 10% and 11.10%. So looking at those are the red and the green dots there. They're kind of mixed in. The average atomic mass is what we're looking for here. Okay, so here's how you calculate that with 3 isotopes. Okay, so the only difference here is that now I have 3 isotopes instead of just 2. So I'm going to take and I'm going to multiply each mass by its percentage. So in this case, it's 24 times 78.90 over 100 plus then 25 times 10.00 over 100 plus 26 times 11.10 over 100. Oops. Ignore that part. 100. Okay? So first I'm going to simplify it. 24 times 78.90 over 100. I get 18.936 plus 25 times 10.00 over 100. 2.5 plus 26 times 11.10 over 100, 2.886. Now, significant figures here, since I multiplied all these things. These are counts, so they're infinite, and I don't really care about the 100, since that's just the definition of a percentage. I want to go by this. It has 4. So I'm going to round this so it has 4, 18.94. I'm going to round this so it has 4. It has 2 right now, so that means I actually get to add numbers, 2.500. And then this one has 4 already, so 2.886. Doesn't change at all. Okay. Now when I add them, this has 3 decimals, 3 decimals. That one only has 2, so my final answer here is going to only be allowed to have 2 decimals. Okay, so 18.94 plus 2.500 plus 2.886. I get 24.326, but because of this, I only get 2 decimals, so I'm going to go with 24.33 AMU. Average atomic mass of a magnesium atom in a sample. Your turn. So I want you guys to pause the video here and calculate the average atomic mass of chlorine. Chlorine has 2 major isotopes, 35 and 37. The 35 is 75.77% of a sample, which in this picture would be the purple. And then the 37 is 24.23% of any given sample, which in this picture would be the green. Okay? So pause the video, calculate the average atomic mass of chlorine. Got an answer? Okay, so first we're going to take the 35, times it by its percentage, 75.77 over 100. Okay, plus the 37, times it by its percentage, which is 24.23 over 100. Get 2 answers, simplify that. We got 26.5195 plus 8.9651. This has 4 significant figures in the percentage, so I'm going to round this to 4, so 26.52. And then this has 4 significant figures in this percentage, so again, round it to 4, so 8.965. 5. Then actually add these together to get my answer. So if I add them together, I get 35.485, which this has 2 decimals and this has 3. So since I'm adding, I go by decimals. So I round to 2, so I'm going to round it to 2 decimals. So this goes to 35.49 AMU. Okay. Okay, so we're going to try another one. This time it's sulfur. Sulfur actually has 4 common isotopes in nature: 32, 33, 34, and 36. Don't ask about 35. It just doesn't really seem to exist in nature. I don't know why. But if you looked at sulfur, you would be able to see several different isotopes. We've got most of it is the sulfur 32. That's 94.99%. But 33 would be these little green ones here, and 34 would be the red ones, because you have 4.25 of that. The 36, there's actually one of them way down here, this blue one. It's very, very small, tiny little amount of it, but it's there. Okay, so take a moment and calculate the average atomic mass of sulfur, in this case, 4 isotopes. Got an answer? Okay, so setting this up, we have 32 times its percentage, 94.99 over 100, plus 33 times its percentage, 0.75 over 100, plus 34 times its percentage, 4.25 over 100, plus 36, remember no 35 here, times its percentage, 0.01 over 100. Okay, so simplify this. This first one is 30.3968. This next one is 0.2475. This one is 1.445. And then this one is 0.0036. Okay, now significant figures here. This one has 4 for the percentage, so I get to round this to 4. So this goes to 30. And that rounds it up to 40. The 6 rounds the 9 up, which rounds the 3 up. Okay. This next one has 2. Right? 2. That's it. So this one goes from 2.475 to that rounds it up to 2.5. 2.5 there. Okay. This one has 3. 4.25 has 3. So we're going to round this to 3. That goes to 1.45. The 5 rounds it up. Okay, and then this one has only 1, so we're going to round this to 0.004. Okay, add these together, and we get 32.104. Now, this has 2 decimals, 2 decimals, 2 decimals, 3 decimals. So even though this goes to the 3rd decimal, we have to round to 2. So we're going to round this to 32.10 here, AMU. And there's the average atomic mass in a sample of sulfur. Now, last but not least, sometimes I ask, looking at the periodic table, you can actually tell which isotope is actually going to be more common in a sample. So let me show you what I mean by this. I've got 3 elements here, and I've also listed how many isotopes they have, what they are. Okay? Now, here's a copy of the periodic table of elements. So, this first one here, nitrogen. It has 2 isotopes, 14 and 15. Nitrogen 14, nitrogen 15. So what I'm going to do is I'm going to find nitrogen on the periodic table. There it is. Okay. The average atomic mass of 14 listed on the periodic table is 14.01. So if there are 2 isotopes, these 2, and it's 14.01, okay, essentially what we're doing here is we've got 14 times some percentage plus 15 times some percentage equals 14.01, okay? So if that's sort of my math problem here, which one do I have more of, the 14 or the 15? Well, it's so close to the 14, you can see that I probably have like 99% of the N14 and only like 1% of the N15. All right? So I would have more. I was asking which one do I have more of here. I would have more of the N14 here in that sample. Okay? So what I want to do here is have you guys pause the video. Lithium. Take a look at lithium's mass on the periodic table, the average atomic mass. There's two isotopes there, lithium-6 and lithium-7. Which one does a sample of lithium probably have? A natural sample of lithium probably have more of, 6 or 7. And the same thing for argon. Which one? It has 3 here, so 36, 38, and 40. Look at argon's average atomic mass on the periodic table. Which one is that probably the most common here? Got an answer? Okay. So periodic table, I'm going to zoom in here. First things first, lithium. Right there. Average atomic mass is 6.94. So if we're trying to decide if it is 6 or 7, it is closer to 7 here. Like, I would say it's probably about 90% lithium-7, maybe about 10% lithium-6 to get an average atomic mass like that. So it's mostly lithium-7 here in a sample of lithium. For argon, argon's over here. Average atomic mass is 39.948. So if I have a 36, a 38, and a 40, well, it's really close to 40. So I'm going to say that it's like 95% of the 40. And then the rest is the 36 and the 38. So it's mostly argon 40 in that sample. And that's it for calculating the periodic table of elements atomic masses. Now, I will say this, when you guys are working on these, the percentages I'm giving you in the problems and on this video do not perfectly match what we have on the periodic table. So they're just slightly different from what's on the periodic table. For example, my answer for copper was 63.62, whereas the periodic table says 63.546. This is an accurate one, but in order to calculate, to show you how these were calculated, some of these percentages are slightly different than what they would be in real life, just so that you're not getting the exact same answer as what's written on the periodic table. And you can't just pull out your periodic table and copy the answers down and call it good, right? So these answers on these worksheets I'm giving you over the next day or so will be slightly different than what's on the periodic table, but they will be close.